Now, in this video, we will going to discuss about the general concepts of the fourth quadrant. So what is the condition for the point to be in the fourth quadrant? The condition has to be the point is below HP, in front of VP, or in front or behind or from RPP. So condition with respect to VP is front view, and therefore condition with respect to RPP is in front, so in front of RPP. The final condition is below HP, in front of VP, and in front of RPP. How? We will go to see now. Suppose if I look from the front view, I can see the distance below HP, and when you look from the front view, the image will going to fall on the vertical plane, which is small d dash, and so this will going to be below HP. Similarly, when you look from the top view, I can see the distance in front of VP, that is this distance, and when it is projected, that point will going to lie on the horizontal plane, and so this distance will going to become in front of VP. Now we need to see the image on the profile plane. If you want to see the image in the profile plane, then I can see either from the left side view or I can see from the right side view, because the planes are transparent, point number one. And the number two is both LSV and RSV is perpendicular to the right profile plane. So that is the reason why you will be able to see both the views. But which view is correct, we need to understand now. So to do that, we have the condition of observer. That means when you look from the front view, object is between plane and observer. And when you look from the top view, plane is between the object and the observer. If you look from the left side view, object is between the plane and the observer. And similarly, when you look from the right side view, plane is between the object and the observer. So always it should satisfy the condition of the front view, because VP and RPP both will be on the same side. So that condition is satisfied only when you look from the left side view, the point is or the object is between the plane and the observer. Even the front view is also the object is between the plane and the observer. Therefore, in the fourth quadrant, if the point to be seen in the profile plane, then the condition has to be in front of RPP. So in front of RPP is which distance? That is this distance. When you look from the front view, you can see here it is in front of RPP, and when you look from the top view, this in front of RPP is seen here. Now when you look from the left side view, we can see the distance below HP and also in front of VP, both. So below HP distance is seen in the profile plane, and also in front of VP is also seen in the profile plane. In other words, I can see the distances of both front view and as well as the top view. So both D dash and D double dash both will going to lie on the same plane. So this is how this is how we can analyze the projection of point in the fourth quadrant. Now what we do is we will going to cut it here on this side and rotate HP down and RPP to the right side. See what happens. So here, when you do that, the point is below HP and in front of RPP when you look from the front view. So that means now we are going to take up individually. So when you start from below HP and in front of RPP in the front view, so when you look from the front view, I can see the distance below HP that is projected onto the vertical plane. So we will going to get the below HP here. And also in front of RPP is this distance when it is projected. So that line will going to fall on the vertical plane here. So this distance is in front of RPP. So therefore, in point is below HP and in front of RPP is seen in the front view. So distance with respect to HP and RPP is always seen in the vertical plane. So image is the front view. So that means if the distance is given with respect to HP, then you take it in VP. This is applicable irrespective of all the quadrants. Even in the first quadrant also the same, second, third, and this is also, the fourth is also the same. Now we will going to look for the top view now. In the top view, in front of VP we can see, and also in front of RPP. That is seen in the top view. How? When you look from the top view, I can see the distance in front of VP, that is this distance, and when it is projected, that will going to fall on the horizontal plane, which is small d. So this distance will become in front of VP. And also when you look from the top view, I can see the distance in front of RPP. When it is projected, that will going to fall here. So this will going to be the in front of RPP. So distance with respect to VP and RPP is seen in the HP, and the image is the top view. Now we will going to see what is the position with respect to the left profile plane or right profile plane. Point is in front of VP and also below HP is the left side view. So distance with respect to both HP and VP is always seen in the right profile plane. So image is the side view. So LS view because the point is in front of RPP. Now when you look from the left side view, I can see the distance below HP. That image will going to falls on below HP in right profile plane. And also I can see the distance in front of VP. So that distance will going to be seen here as in front of VP. Now when you rotate this, so VP is always fixed and HP is rotated by 90 degree clockwise and RPP is rotated by counterclockwise direction. So this is the intermediate position of the position how it will going to be rotated. So it will be with a less angle and this with a more angle. So that finally this both VP and HP will be overlapping and RPP will go to the right side and always RPP will be adjacent to VP. So that is the reason why when we want to decide the right side view, we will always take the condition with respect to VP. Now, here in the final view after the rotation, so you're going to get both VP and HP will be overlapping and right profile plane will be here, and then it is below in front of RPP is seen in both VP and HP. So you take from this and you take in front of RPP, and the below HP distance it will going to be here on the vertical plane. It becomes front view. And in front of VP is on HP. So HP means it is the top view. So you're going to get small d. And then we look from the side view, we can see both the distances of front view and as well as top view. Here the below HP when it is projected, so it will go directly onto this profile plane. And in front of VP is vertical here has to become horizontal. So when you project this here, so this will going to become in front of VP. And draw an angle at 45 degree. So what happens? In front of VP, which is vertical here, is transferred to the horizontal distance, and where you have the front view on that line, we will going to get the side view. So then you project from here, so that both D dash and D double dash will going to lie on the same line. So now we will go for the orthographic view of this. So draw XY and X1 Y1 line, and the distance with respect to the profile plane is you have to take first because that is seen in both VP and HP. Identify the planes VP and HP and RPP. Then from X1 Y1 line, you take the distance of in front of RPP and draw a vertical line, vertical projector. Then you take the distance of below HP, which will be on VP. Since the image is on VP, so you're going to get D dash. And again, you measure the distance from here to the in front of VP, whatever the distance is given. So you take that in front of VP. So the distance, both D dash and D dash, position of D dash and D, both will going to depends upon the condition what you have given here. So that means the distances here in front of VP is more than the below HP. So that is the reason why it is coming like this. In sometimes below HP will be more and in front of VP will be less. The conceptual wise, this is the drawing. Then when you see from the front side view, we can see both below HP and also in front of VP. So below HP is vertical here, below HP is vertical here, and below HP is also vertical here. So you try project this directly onto the profile plane. RPP, right profile plane. Then you want to transfer the distance of in front of VP, which is vertical, has to transfer it into horizontal. Then adjacent to HP, you draw a line which is inclined at 45 degrees, and then project the top viewpoint onto that 45 degree line. And from this intersection point, then you draw a vertical project to the top side, and where D dash is there on that line, both will go to intersect, and you mark this point as D double dash. So this is how you will be able to analyze the projections of points in the fourth quadrant. In the next video, we will going to take up the problems on projection fourth quadrant problems. Thank you.